Hey guys, today we're going to talk about systems of equations. First, we're going to define systems of equations, and a system of equations is just two or more linear equations That's it. Sorry, I thought there was more. Two or more linear equations. That's it. So it's just more than one equation. So types of solutions. So when you're trying to solve a system of equations, that means that you want to find a point that they have in common. So if I give you two different equations, we want to try to find the place that they intersect, where they include the same point. So one type of solution is when we have one solution. And an example of that might be this line and this line. And they cross at one point. So where they intersect at one point, there is one solution. For no solution, what that looks like is when you have two lines that will never ever touch each other. And that means that they must be parallel. So these are intersecting. These are parallel. And then infinite solutions happen whenever you have two of the same line. Because sometimes you can simplify two different equations and end up with the exact same function. And so in that case, there are infinite solutions. So this would be same line. Okay, let's look at some examples. So for number one, we have a system of two equations. And like we said, that just means that there are two or more equations. That's nothing else. So what we're going to do is solve these by graphing them. I just showed you the different types of solutions and how they look on a graph. So we are going to graph each of these equations and then try to find the solution. So to the system, yeah. So for the first one, we start at y equals -6. So that's down here. And we go to our slope now. Okay, we started at -6 because that's the y-intercept. Now we look at our slope, -5/3. That means that we need to go down 5, right 3, which we run out of room for. But it would be like somewhere in here. Or we can go up 5, 1, 2, 3, 4, 5, and left 3, 1, 2, 3. Then up 5 again, 1, 2, 3, 4, 5, left 3, 1, 2, 3. And that is all the lines that we can fit on our graph. So we're going to just go ahead and connect those. Oh, that was a terrible one. Okay, I'm not sure what I was thinking. You can fit one more dot on here if you go up 5 and left 3. But there's our line for the first graph. So we've graphed that one. Now we're going to graph the second one. We start with the y-intercept, which is at +5. So go to +5 on the y-axis. Let me use a different color so they're easy to tell apart. And then we have a slope of +1/6. So we are going to rise 1, run 6. 1, 2, 3, 4, 5, 6. Rise 1 and over 6 would be somewhere over here. So now we go down 1 and left 6. So down 1, 1, 2, 3, 4, 5, 6. And here's one point. And then the next point would go off our graph. So then we're going to connect our lines, roughly. And now we want to just identify the point that these two graphs have in common. And that point is right here. And if we look at the x value of that, it's -6. So our answer is going to be a coordinate, x, y. So negative 6, and then this goes to positive 4 on the y-axis. So this is the answer that we're looking for, but you do have to show your whole graph. All right, let's do another graphing one. Remember that there's two ways to graph equations. You can either find the x and y intercepts and graph from that, or you can move it into slope-intercept form. And I'm going to choose slope-intercept form, but if you prefer a different way, that's also fine. So we're going to start with this one. And we are going to start by subtracting 6x from both sides. So 6x minus 6x is 0. 0 minus 5y is negative 5y. And then negative 45 minus 6x, those cannot be combined because they are not like terms. That's going to leave us with negative 45 minus 6x. We're just going to write it out. Now, we want y to be by itself. So it's being multiplied by negative 5. That means we need to divide every single term by negative 5. And that's going to leave us, negative 5 over negative 5 is 1, and 1y just equals y. Negative 45 over negative 5 is positive 9. And then negative 6x divided by negative 5 is positive 6/5 x. But we want this to look like y equals mx plus b. So we want to switch these two. And since they're on the same side of the equation, we can just pick them up and move them. So it's 6/5 x plus 9. Let's go ahead and graph that one while we're looking at it. So we go to positive 9, that's our y-intercept. And then we have a slope of positive 6/5. Well, if we were going to go up 6 and over 5, that would be way up here somewhere. So instead of going that direction, we're going to go the other direction, and it's just you take the opposite of both of them. So we can go down 6, 1, 2, 3, 4, 5, 6, and left 5, 1, 2, 3, 4, 5. And if you remember from a couple of assignments ago, whenever you have a positive slope, that means that your graph should increase from left to right. And so since 6/5 is positive, we can kind of double check that this line is going to increase from left to right, and so we are on the right track. So let's do it one more time. Down 6, 1, 2, 3, 4, 5, 6, and left 5, 1, 2, 3, 4, 5. So we now have a line for our function. And let's try the second one. We need to convert it into y equals mx plus b. So we're going to start by subtracting 2x from each side. And that's going to give us 0 plus 2y, which is 2y, equals negative 4 minus negative 2x, or minus 2x is just negative 4 minus 2x. We can't combine those because they are not like terms. So then we need to divide everything by 2 to get y by itself. 2 divided by 2 is 1, and 1y is just y. Negative 4 divided by 2 is negative 2. Negative 2 divided by 2 is negative 1x. Now, remember we want mx plus b, so we're going to have to swap these two. And you always keep the sign to the left of it. So like this is one term and this is one term. So when you pick them up and move them, you have to keep the signs. So it's going to be y equals negative x minus 2. So let's graph this one. We're going to start at the y-intercept, which is negative 2. And then our slope is negative 1, which can also be written as negative 1 over 1. So we're going to rise negative 1, run positive 1. So that brings us here. And that is a simple enough pattern that I can see how this is going to go for the whole rest of it. And I don't even have to count those points. I can just dot, 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 and then connect them. And which point do they have in common? This one right here. And we need the x and y values. So the x value, remember this is the x-axis, is negative 5. And I found that by finding what number it leads us to. And this one is positive 3. And that is our answer. And I'm going to help you solve one more by graphing, and then you can do the even graphing problems. So we're going to start by putting them in slope-intercept form. So in this one, everything is in the right position. We just need to divide everything by 2 because we want y to be by itself. And so 2 divided by 2 is 1, and 1y is just y. 8x divided by 2 gives us 4x, and 18 divided by 2 gives us 9. And that equation is ready to graph. So we go to positive 9 on the y-axis, and then our slope is 4. And remember, anytime you have a whole number as a slope, you can just put it over 1. So we're going to rise 4, run 1. Well, if we rise 4, that goes off our graph. So we can also switch both signs, which gives us negative 4 over negative 1. And that means we will rise negative 4 and run negative 1. And we're just going to keep doing that. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. And that's all that'll fit. So let's connect our dots. All right, now graph number 2. Here's what we're starting with. I want to get y by itself, so we're going to subtract 24 from both sides. Let me just rewrite this. 24 plus 4y equals x. Minus 24 minus 24. These give us 0, and 0 plus 4y is 4y. And x minus 24 cannot be combined because they are not like terms, so we just get x minus 24. Now we have a 4 with our y. We want to divide by 4 on every term to get rid of that. So 4 divided by 4 is 1, and 1y is just y. 1x divided by 4 is 1/4 x. And negative 24 divided by 4 is negative 6. So now this equation is ready to graph. We start at y equals negative 6. And then we have a slope of 1/4. And so what that means is we are going to rise 1, run 4. Rise 1, run 4. And again, and then this way, and then we connect our dots. And those two have this point in common. And that point is represented by negative 4 on the x-axis and negative 7 on the y-axis. So our answer is negative 4, negative 7. Remember, that's always in order, x, y. Okay, so if I were you, I would pause the video here. I would complete the even graphing problems while this is fresh in your memory. But the next thing we're going to cover in the video is solving by substitution. And here is a layout of the rules that we're going to use. And you're going to see the same type of problems, you're just not going to have a graph. So that means that we are going to just have two equations and we're going to have to solve for the point they have in common. So what this says is that we're going to take one equation and solve for x or y. We can pick whatever's easiest. We just need to isolate a variable. Then we're going to substitute the resulting equation into the other equation. Then we're going to solve for the other variable, and then we're going to solve again. So it's a lot of steps, and I know that I just abbreviated them, but I want us to understand what I'm talking about in the next slides. Okay, so we have two functions here, and we're just going to follow step by step to try to solve the point that these have in common. So step 1 says to solve one equation for x or y. Well, both of our equations are solved already for y, so we actually don't have to do any work for that step. We're just going to pick one. let's say we picked this one. We did it. We solved for y. Substitute the resulting equation from step 1 into the other equation for that variable. So what that means is we are going to take everything that y equals, which is all of this, and plug it into the y spot in the other equation. So we're going to have x minus 9 equals negative 7x minus 1. Okay, this is y equals negative 7x minus 1. And then we're just going to solve for x because now we only have one variable in here and it is x. So I'm going to add 7x to both sides. And there are multiple ways you could tackle this. You don't have to use my exact method. You could have added 9 or added 1 or subtracted x. There's lots of different ways you can solve this equation for x, but you just need to be able to solve for x. So that's what we're doing. Here we have 8x equals 8. When we divide both sides by 8, we get x equals 1. So x equals 1 is part of our solution, but we substituted, did that, and then we already solved for the remaining variable because x was the only variable in there. But now we need to substitute your answer from step 3 into the either original equation to find the other variable. So we can pick either one that we want. I'm going to pick this one because it just looks simpler. There's less numbers in it. It looks easier. And you can do that. That's fine. So we are going to say y equals whatever x was minus 9. And we found out here that x is 1. So when we plug 1 in, we have y equals 1 minus 9. That means that y equals negative 8. And so again, we write our answer as a coordinate as an ordered pair. And that is 1 comma negative 8. X always comes first in an ordered pair. And that's our answer. And if you were to graph these two equations, you would find that that is the point where they intersect. So let's try another one of those. Our first step again is to solve one equation for x or y. I'm noticing that y is by itself here. There's no coefficient like there is on all the other variables. So I'm going to choose to solve this equation for y because I think it will take the least amount of work. So in order to do that, we're going to subtract 7x from both sides. And we're going to get 7x minus 7x is 0 plus y is y. And then 22 minus 7x, you cannot combine that, so we just have 22 minus 7x. And in this scenario, we are not trying to graph these, so you don't have to put them in y equals mx plus b form. You can just leave it in this form right here. Not a big deal. So we have solved for y in one of the equations. That's what we wanted to do. Now we want to substitute that into the other equation. So we're going to take everything that y equals, here, let me rewrite the other equation. 6x minus 5y equals negative 28. We're going to take all of this and plug it in for y. So we have 6x minus 5 times all of y, which is 22 minus 7x, equals negative 28. So then we have x's only, and that means we can solve for a variable. So the first thing we'll do is distribute the negative 5. 6x minus 110 plus 35x equals negative 28. And in case we don't remember, the way that I got these numbers is by multiplying negative 5 by everything in the parentheses. So negative 5 times 22 is negative 110. Negative 5 times negative 7x is positive 35x. Now we're going to combine like terms. 6x plus 35x is 41x. Bring down the minus 110 equals negative 28. Then we are going to add 110 to both sides. This equals 0, and so we're left with 41x equals 82. And when we divide both sides by 41, we get x equals positive 2. So we have substituted and now we've solved. Now we're going to substitute x back into either original equation, it does not matter which one, and solve for the other variable. So solve for y. Again, I think this equation looks like less work. That's where I'm going to put my x. So 7 times 2 plus y equals 22. So 7 times 2 is 14 plus y equals 22. Subtract 14 from both sides, and we get that y equals positive 8. And so we write our answer as an ordered pair, 2, 8. And that's your answer. Good job. So this is the last problem that we're going to do together, and then I'm going to let you go and practice the even ones on your own. So step 1, solve one equation for x or y. I'm going to pick this one because y is already on its own side of the equation. We just have to divide everything by 2. So that's what we're going to do. That was beautiful. So we get y equals 3x plus 5. So that was easy enough. So now we're going to take 3x plus 5 and plug it in for y here. And that will give us 3x minus 3x plus 5 equals 5. So remember, anytime there's no coefficient, there is an invisible 1. You can just write that 1 in. And then we're going to distribute that negative 1. So 3x minus 5 equals 5. And 3x minus 3x is 0. So now we just have negative 5 equals 5. So remember, anytime that our variables disappear, we ask ourselves the question, is this statement true or is it false? If it's true, then the answer is all real numbers. But in this case, negative 5 does not equal positive 5. So the answer is no solution. So these would be parallel lines because they never ever cross. That's all for today. Thank you guys for listening.